This is Math 2 4.2 notes. That's Unit 4, Lesson 2. Today's lessons regarding perpendicular bisectors. You should have received this handout and printed it off of my website. Okay, perpendicular bisector theorem. If a point lies on the perpendicular bisector of a segment, so here's the segment, and CD is the perpendicular bisector. Any point on CD, then it is equidistant from the endpoints of the segment. Okay, so what that pretty much is stating is if AB is perpendicular to CD and AD is congruent to DB, meaning it bisects, so that shows the perpendicular, that shows it bisects, then AC will always be congruent to CB. AC will always be congruent to CB. All right, and that is true for any point on the perpendicular bisector. For example, this perpendicular bisector, this CD could go up further, and any point that I connect on this line that I connect to A and to B, which are the endpoints of my segment here, will always be congruent. If I had picked a point way up here and connected, those two segments would be congruent. Okay, the converse of the perpendicular bisector theorem is also true. If a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector. So if a point is equidistant from the endpoints of a segment, here, if they're congruent, then it is on, this point here is on the perpendicular bisector of the segment. Okay, a really quick side note, remember we talked about isosceles triangles. Do you see the isosceles triangles here? It was a theorem we had on lesson 3.5 that stated if a line bisects the vertex angle of an isosceles triangle, then the line is also the perpendicular bisector of the base. And we didn't put here, but we should have, the converse is also true. It goes both ways. If it's an isosceles triangle and you have a perpendicular bisector, it also bisects the angle, the vertex angle. Okay, so we're going to put that little side note here because that is something we will use. The perpendicular bisector is also an angle bisector. Okay, so when you're dealing with these isosceles triangles, which the ones we're dealing with in this particular lesson will be, the perpendicular bisector is also an angle bisector. Okay, so I'll put here when it is an isosceles triangle, which we will be dealing with in this lesson. All right, vocabulary that you will need to know for the test. Circumcenter. The circumcenter is the point of concurrency, which is where all the points intersect, of the perpendicular bisectors of the sides of a triangle. The circumcenter is equidistant from the blank of the triangle, from the vertices of the triangle. All right, so if these are all perpendicular bisectors, that means they cut all of the segments in half. So that's congruent to that. So these two are congruent over here, and these two are congruent over on the other side as well. Okay, so if you were to go through and draw perpendicular bisectors for all three sides, they would always meet up at one point. That point of concurrency is called the circumcenter. Now what's cool about the circumcenter is right here. This is something that will come up. It's equidistant from the vertices. There's three vertices, 1, 2, 3. So if we were to go through and take this point of concurrency and connect it to each vertex they would all be equal to each other. Let's see if I can draw this one here. Okay, so if you were to take the point of concurrency and connect it to each vertex, they would all be equidistant. Oh, just made a mess of my paper. Okay, so I'm just going to put some quick markings in here. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. All right, moving on, find the length of MN. Okay, now notice they gave me congruent markings here, but none here. I do not know from what just the picture, looking at it at a quick glance, I do not know if these are congruent. But perpendicular bisector states that if this point is on the perpendicular bisector, it's equidistant from the endpoints. So without telling us, we should know from the perpendicular bisector theorem that these two segments are congruent. Why? Because this vertex here lies on the perpendicular bisector, so it's equidistant from the endpoints. So you're ready to solve. 4x plus 19 equals 6x minus 7. I am going to subtract the 4x, 19 equals 2x minus 7. I'm going to add the 7 to the other side, giving me 26 equals 2x. Divide both sides by 2, and x equals 13. And being very careful, some up here, but what is it asking for? It didn't just say find x, it said find mn. So I'm going to use that to help me find it. Where is mn? Mn is here. Mn equals 4x plus 19. 4 blank plus 19, because I'm going to now plug in the x value. And 4 times 13 is 52, plus 19, mn equals 71. Okay, next problem. JL. Now again, so this is the converse. These sides are congruent, but it doesn't say anything about that. If it's an isosceles triangle and this is perpendicular, it also bisects the base. So you should know that those are congruent. 3x plus 4 equals 5x minus 16. I'm going to have you guys solve that on your own. Check it with me in class. Remembering at the end, they want you to find the length of JL. JL is all the way across. So think about where you're going to plug in the x and what you're going to do to find the length all the way through. And we'll check our answers together in class. Okay, next page. RT bisects SU. RT bisects SU. So that means that these segments here are congruent, and it shows there that it's perpendicular. Find each measure. ST. Okay, so if this is a perpendicular bisector, that means these segments here are also congruent according to the perpendicular bisector theorem. So ST is congruent to that side, so it is 23. SV, well, we put those markings already because it said it bisected SU, so SV is congruent to UV, so this little segment here is 5 as well. And if they're each 5, what is the total segment all the way through? 5 and 5 is 10. Okay. See here how this is a perpendicular bisector and it's an isosceles triangle. We know that because if it's a perpendicular bisector, then that point there is equidistant. Therefore, it's isosceles. Therefore, these angles here are congruent. So it didn't mark it for us, we just need to know. 12x plus 5 equals 4x plus 21. I'm going to have you solve that one on your own. Noting here, all they're asking for is x. So when you find x, you are done. All right, next one. QT is on the perpendicular bisector of PR. Okay, here's QT, and here is PR, which means that this segment is congruent to that, as well as that segment is congruent to that. And we know that because it said bisector, so we know it cut this in half, and then we know those are equidistant. Find each measure. Okay, so if these two are equal, we can find Y. PQ, where's PQ? So after you find Y, you're going to plug it in. There and there, I'm going to have you guys do that on your own. PT, you're going to find Y, plug it in there to find PT, and then PR. Going to plug that in, and we're going to check all these answers together. And I want you to try this last one on your own as well. If Z is their circumcenter, and we talked about circumcenter on this side and what is going on, then of the triangle T, 3 measures, and you definitely have enough information. You might have extra, but you have enough to answer these 3 questions. So you're solving for X, you're filling in for these 2 as well, and finishing up this one. And we'll compare answers together in class.